little bit of solving quadratic equations. Remember, standard form of a quadratic is this red guy that you see right here, ax squared plus bx plus c equals 0. The first method that we're going to do today is called the square root method. It's what we're very familiar with, and you can only do it when b equals 0. So like here, a, b, and c are numbers. If b equals 0, that means that that term doesn't even exist. You can see in these equations down here, that's a great situation. So we're going to do the square root method. And the idea is to get x squared all by himself on one side of the equal sign. In this first equation, x squared is all by himself. So the way you can get rid of it is to square root both sides. So if you square root this side, square root this side, then x will equal plus or minus, don't forget about that, the square root of 25, which is 5. That came out real nice. This guy here, we got to get x squared all by himself, so we need to subtract 2 from both sides. So now I got x squared by himself. I can square root both sides, and x will equal plus or minus the square root of 9, which is plus or minus 3. And then here, getting x squared all by himself, I'm going to add 24 to both sides. Then, of course, I'll divide by 2. And oh no, here's our first situation where we don't have a perfect square over there. That's okay. We'll still square root both sides, and x will equal plus or minus the square root of 12, which we can simplify that. If you remember, we find the biggest perfect square that goes into 12 evenly, which is 4. So we've got ourselves plus or minus 2 square roots of 3. That's how my open math will probably want our answers. And then if we go over here and solve this guy, we'll get x squared by itself. Oh no! We get a negative guy, which many times you are trained to realize there's no real solutions to that. That's correct. There are no real solutions, but we can get imaginary solutions. So we're still just square rooting both sides. And, yep, we're going to get some imaginaries, but please don't let that freak you out. Just pretend that number was positive for a second and take its square root. Isn't the square root of 4 totally 2? But the negative part just means you're going to put an I with it. So plus or minus 2i in that situation. And then the weirdest part about these last two guys on the square root method is you see, we still have something squared all by itself. If I can get my shape maker here, if you just take a blind eye to what's in the parentheses, like if you can't see what's in there, it's like we're still just going to square root both sides. So you're trying to get the quantity squared all by himself, so those cancel each other out, and you're left with whatever was underneath there in that parentheses, which in this case it's x minus 1. So, okay, the x minus 1 comes down, and don't forget you get plus or minus the square root of 11, which the square root of 11 doesn't even simplify. There is no perfect square that goes into it. But what we got to do is still get x by itself, so we will add 1 to both sides. And you can't add normal, regular old numbers and radicals together, so our final answer is 1 plus or minus the square root of 11. You might have to realize that there's two answers there, like if the homework wants you to punch them both in, there's still two answers here, like this is 5 and negative 5, like two answers. So over here, again, just pretending you don't see what's in those parentheses. Take a blind eye to what's in there. You're going to square root both sides. So we're going to get the square root of this side and the square root of this side. Oh, no! We got a negative. So I got x plus 5. I believe that's what was in there. Yep, x plus 5 coming down. And that'll equal, x plus 5, my bad, plus or minus the square root of, again, pretend that was positive in a second, and the square root of 3 doesn't come out nice, but we're going to sneak that I in there, and the I should actually go in front of the square root symbol. We don't want it on the back side. It's just not proper to do that. And then, we'll solve for x by subtracting 5 from both sides. So what a messy, messy, messy situation. But still, that was a real nice case because that was the square root method. There was no b value. The b value was 0. There's no x's at all in this. Yes, of course, you see these have x's, but again, since they're in parentheses, if you've got something squared all by himself on one side of the equal sign, you can totally square root both sides. Then another method, the one you're probably the most familiar with, is factoring. It's ax squared plus bx plus c. It's got to be equal to 0 first. And this is easy factoring because this a value right here is 1, meaning if you don't even write it because there's like a 1 in front of there. So you can only easy factor if the a value is 1. And this is old school stuff. We've done this many times before. So what you're trying to do is find two numbers that multiply together to be c. That is this blue guy right here, and at the same time add together to be b. This is the hardest part about it. It's finding those two numbers. I like to find their signs first. If they have to multiply together to be a positive 10 and add together to be a positive 7, that means both numbers are positive. So how do you feel about 2 and 5? This is why we're calling it easy factoring, is because there's just not much work that you got to do. You just take those two numbers and whatever letter they're using, you put them in the parentheses. And then we use the zero product property to realize to solve this equation, if x plus 2 times x plus 5 equals 0, one of these guys has to be 0. So x could equal negative 2 because that makes this group 0, or negative 5 because that makes that group 0. Here, to easy factor this, you got to get them equal to 0 first. So I'm going to subtract that 18 over. And again, the only way that we're easy factoring this guy is because the a value is 1. Why can't we use the square root method? Because there's also x's in it. It's got x's and x squared, so we can't do that. I got to find two numbers that multiply together to be a negative 18. Right there, that tells you that their signs, one of them has to be positive and one of them has to be negative. And at the same time, they add up to be 3. So factors of 18, if one of them was negative, like those totally don't do it. 2 and 9, if one of those was negative, those don't add up to be 3. 3 and 6, yes, that's going to work. But which one needs to be negative? I believe it needs to be the, I did the same thing there. It needs to be the negative 3, like that one. This is your bingo right here. They totally add up to be positive 3. So x minus 3 times x plus 6 equals 0. And then to solve, zero product property, x could equal 3. That would make that group 0, or negative 6. And then on the last guy, a lot of people would be tempted to subtract that x squared over here, which you can do, but then you won't be able to easy factor it because you would have a negative x squared, and you want that number in front of there to be a positive 1. So I'm going to move these bad boys over to the left side by subtracting 5x and adding 6 over. And now I got to find two numbers that multiply together to be a positive 6 and add together to be a negative 5. The way that's going to work is both of those numbers need to be negative. So a negative 2 and a negative 3, they totally add up to be positive 6 and add together to be negative 5. If you need help finding these two numbers, you make yourself a list of multiples of 6, or come ask for help from your teacher, and we would be happy to help you. But easy factoring was something that we did many, many, many times in Algebra 1 and probably Algebra 2. So, but that was just a quick refresher. And then the last way of the day is my favorite. It's the easiest one to factor in my opinion. It's called the difference of squares. Difference means it's got to have a subtraction. Boom, boom, boom. Do you see all these guys have a subtraction sign in the middle? And squares means these two guys are both perfect squares. So there, again, the b value is 0. So you could totally use the square root method if you wanted to. And your homework's probably going to ask you to choose whichever way you'd like. But the difference of squares, if the first guy is a perfect square and the last guy is a perfect square and there's a subtraction sign, it's a simple factor to where you take the square root of the first guy. The square root of 9x squared is 3x. The square root of the last guy, the square root of 16 is 4. And then you make these guys, here's a big word, conjugates of each other. Conjugates means one of them's a plus and one of them's a minus. And now to solve this, x could equal the opposite of this guy over that guy, negative 4 over 3. Or opposite of this guy over that guy. This is all stuff that you have done many times in algebra. You may not remember the difference of squares or ever been taught it, but solving for 0 in that, let us know if you need help with this. So this guy right here is totally a difference of squares. He will factor to be conjugates of the square roots. So the square root of 25x squared is 5x, and the square root of 49 is 7, and one of them's a plus, one of them's a minus. No, it doesn't matter which one's the plus and which one's the minus. Just one of them's got to be a plus and one of them's got to be a minus. Then opposite of this guy over that guy is the solution of that. Opposite of this guy over that guy. And then this guy is the most dangerous of them all because he's supposed to be the simplest, and he is the most complicated because, yeah, I'm pretty sure we know one's a perfect square. We just kind of forget about him a lot. So he is totally a difference of squares. So the square root of x squared is x. And the square root of 1 is 1, and then you got a plus and a minus to make them conjugates of each other. So x could equal negative 1 or 1 in that situation. So quick little video. Please let us know if you have any questions, and have a good one.